Now that we know what acids and bases are, we can put a little bit more meat on the electrolyte definition. And here's a quick reminder of what we had after we covered just the ionic substances. So here's definition 1. Definition 1 is the operational definition, and that goes just by measuring conductance. Strong electrolytes show good conductance, weak electrolytes show some conductance, non-electrolytes show vanishing conductance. But that's not really the one we are after, right? So we want the explanation, we want definition number 2, and that's a soluble substance that in solution dissociates into ions. And now that we have acids and bases, we would have dissociates or ionizes into, or forms ions, right? That in solution forms ions. And the strong electrolyte would nearly form to 100% ions. A weak electrolyte would form a few ions, right? Fairly incomplete dissociation or ionization. And the non-electrolyte has no dissociation or practically no dissociation. And now let's put a little bit more meat on this, and let's split it between ionic compounds and covalent compounds, and let's put some examples for every compound class we might encounter here. And this table is fairly dense in information, so let's go over it slowly. We have the electrolyte type here. We have we have strong, we have weak, and we have non-electrolytes, just as before. The definition, we use definition number 2. So we have soluble compound and 100% dissociation or ionization. 100% of the compound form ions, or near 100% form ions. Weak electrolyte, a small percentage of the compound form dissociation and ions, but it's still a soluble compound. And the non-electrolyte is soluble and forms no ions, or practically no ions. And observe, insoluble compounds are not caught here, right? Insoluble compounds would be a totally different entry. I could add another row in the table that said, okay, I have insoluble compounds, right? But I'm running out of space on my slide here. And insoluble compounds don't count as electrolytes at all because they are insoluble. So, big deal. And now I'm coming here to my ionic and covalent columns. So in the strong electrolytes, to have 100% ion formation, an ionic compound will do that every time, right? Because, hey, I already had ions as in the original, in the solid. Ionic compounds are typically solid. And so when you dissolve them, the ions simply separate, and you have 100% dissociation. And they can't do anything else. That's the only thing they can do, because that's the way they are made. They already exist as ions in the solid state. Sodium chloride are ions, and they form ions, of course, when they dissociate. And sodium bromide are ions in the solid state, and anything that goes into solution goes as ions. Covalent compounds is a big exception, right? There's only 6 strong acids around. There's millions and millions and millions of covalent compounds, and there's only 6. That's not many, right? 6 out of millions that form 100% ions. So that's exceedingly rare. There's 6 strong acids. Okay, there's a few more, but 6 common ones. And those 6 common ones, it's really, really advantageous if you know them, because once you know them, you can say, okay, that must be a weak acid, right? It's not so. It's important to know those are strong, and it's important to know the strong ones so you can tell which ones are weak. Because the ones that are not strong are necessarily weak. Right. Weak electrolytes, ionic compounds, how can they? Right? I can't do that with an ionic compound. It exists as ions, and if it goes into solution, it will go as 100% as ions into solution. It can't go as 5% and remain 5% and remain 95% undissociated. That doesn't happen. It cannot happen by definition of what an ionic compound is. So that just doesn't exist. If you don't understand that, go back to the slide of the ionic compounds. Look at this slide. An ionic compound already exists, consists of ions. As what should it go into solution? It can only go as ions. That's a big conceptual issue. It's important. Then on the covalent column, we can have that, right? Because those are molecules, and it's rare for molecules to split into ions. And there were just 6 who did it really strongly, but there's a bunch of them who do it to some percentage, not to a big percentage, but to a few percent. And that are the weak acids and the weak bases. So HNO2 is a weak acid because it's not one of my 6 strong acids, so it's a weak acid. And then ammonia is the prototypical weak base, but then all the amines, all nitrogen, and then replace this hydrogen with any type of organic functional group will be a weak base. So those do that, but those are kind of, again, not super exceptional, not as super exceptional as the strong acid, but they are exceptional. They're a fairly short list of those. And then the non-electrolytes, they're just plain soluble, but they don't show any noticeable dissociation or ionization. And again, for an ionic compound, I can't have that. I can't be soluble and at the same time form no ions. That is in principle impossible, same as here. It cannot happen. And on this side, there's plenty, right? Most of the covalent compounds that are soluble fall in fact into this class. Alcohols, sugars, aldehydes, you name it. There's plenty of covalent compounds that are soluble or miscible with water. We very often say miscible with water for this class, and then those don't form any ions. And that's the norm for covalent compounds. So that's my beef really here. Ionic compounds can only be insoluble or strong electrolytes. Covalent compounds are the troublemakers, right? Covalent compounds can be insoluble, like a fat, or they can be non-electrolytes, or weak electrolytes, or strong electrolytes. So they make our life troublesome, because they can make so many different cases. And here's where I can only emphasize again, this pattern recognition bit. If you have an ionic compound and my life is easy, I only need to be able to tell, is it soluble or insoluble, and then done deal. Or it's a covalent compound, and is it a strong acid, is it a weak acid, is it a weak base, and so on. That's crucial for this class. And the sooner you kind of get into this pattern recognition groove, the more you will succeed with the chapters we're going into. All right, enough preaching.